Welcome, science students. Today's lesson is about energy sources. We're going to learn about some of the different resources we use to meet our energy needs, as well as the advantages and disadvantages of using each resource. All of these resources are either non-renewable or renewable. Non-renewable energy sources cannot be replaced quick enough. They're used up quicker than they form. Renewable energy sources, on the other hand, can be replaced. They are recreated or replaced quicker than we use them. Some of the non-renewable energy sources we have are things like coal, petroleum, also known as oil, natural gas, and nuclear power, and that comes from the element uranium. Coal formed millions of years ago. Lots and lots and lots and lots of plants died and were preserved in swamps. They were buried under layers of sediment and water. These layers built up over time and compacted and compressed that plant material to the point that we were left with coal. Chemical reactions changed the molecules within that plant material to create a very condensed, compacted energy source of coal. Coal, all of that energy originated from the sun. It was then transformed into that plant material through photosynthesis and then those other heat and pressures that turned it into the current form of coal. Coal is very, very important. We use it for about 14% of our total energy. All of the energy we use. This includes things like the energy we need to power our houses, to run electrical equipment, electricity. It also includes things like transportation energy needs and heating and cooling energy needs. All of those put together, what we mean by total energy. But coal is even more important when it comes to electrical energy. It accounts for about 30% of the total electricity we use in the United States. It's also used to create important building materials like steel. Any major commercial building, anything over a couple of stories tall, is going to contain lots of steel in it. And the US has a lot of coal. We're lucky. We've got a lot of this resource here. We've got over 250 billion tons of coal. And at the current rate that we use them, this could last us another 300 years before we would run out of coal. But it does have some pros and cons, some advantages and disadvantages. One disadvantage to using coal is that, of course, when it gets burned, it releases CO2 in the atmosphere and lots of other greenhouse gases. It's a key contributor to greenhouse gas. But coal is also very abundant. And we use it a lot already, which means we don't have to build anything new. It's already in place. All the facilities, all the infrastructure is there and ready to be used. And this helps it be something that's very inexpensive as you talk about the cost of the actual energy itself. For a unit of energy, it's very, very cheap. But coal burning also creates things like sulfur dioxide. Sulfur dioxide can contribute to things like air pollution as well as acid rain. Both of these can have very negative effects on the environment. The processes to get coal out of the ground can have very negative effects on the environment as well. For instance, there's generally two methods, either an open pit mine where they dig down the entire area until they reach the coal and just strip the entire earth, or they dig down and tunnel out the coal. Both of those can affect the environment in negative ways. Another non-renewable energy is petroleum. And we've got petroleum and natural gas both grouped together because they are created in very similar ways. Petroleum and natural gas also formed millions of years ago, just like coal. But instead of being plant material, petroleum and natural gas were both plants and animals, and these occurred in the ocean as opposed to in swamps. They again became buried under sediments. Lots of layers build up, and that helps to create heat and pressure. That heat and pressure chemically changes the organic material of the plants and animals from the ocean into oil and natural gas. The big difference between how petroleum and natural gas forms deals with the amount of material. For instance, more plant material tended to make petroleum, whereas more animal materials tended to make natural gas. And then the intensity. It takes a bit more heat and pressure to create natural gas than oil, but they both occurred in very similar ways. Petroleum, there's lots and lots and lots and lots and lots of energy in petroleum. And again, it all started from the sun and was harnessed through photosynthesis. Petroleum can be used to create many different resources, from jet fuel that helps us do air travel to plastics, asphalts that cover our roads, heating oils that are used in our houses, as well as gasoline, which powers our cars. Petroleum's major use is gasoline. In fact, we use about 898 million gallons of oil a day. It creates about 37% of our total energy in the US. It's not really used much for electricity, but it's very, very important in transportation and then industrial uses as well. Things like the manufacturing processes. Again, every resource is going to have advantages and disadvantages. Petroleum is super useful. It's used in so many things. It's hard to think of everything we would lose if we no longer used petroleum. Petroleum's uses are already established. We've already got the facilities in place. We already know how to make plastics. We can already use it in all of these different things. So it's got a history. And then there's also a lot of energy in the actual amount. So it's very, very high density energy, lots and lots of energy in a very compact package. Some of the disadvantages include things like drilling and transporting. As you're drilling for oil and as transporting oil in pipelines or tankers or trucks, they can create oil spills if we have accidents, and that oil then seeps into the environment. Burning petroleum, again, creates many of those greenhouse gases that contribute to global warming and affect our air quality. And then oil can really be affected by supply and demand. Oil is found in many more limited areas, and certain countries and societies and places can decide when and when not to sell oil. Chemical energy, again, stored in bonds of the petroleum molecules, started with the sun. It's responsible for 29% or so of our total energy, and it's another major one used in electricity. Again, about 30% of our electricity. So natural gas and coal are two of our huge electricity sources. Natural gas is a collection of many different types of gases. The one that you're probably most familiar with is propane. Propane is what we use to cook in our homes. It's also what we use out on the grill when we're barbecuing and things along those lines. So propane is something you're probably familiar with. It's used lots of different ways as well. Electricity, it's used in our homes. It's also used in those industrial applications, manufacturing processes, things like that. Out of all the fossil fuels, natural gas is the cleanest. It's very, very clean when compared to coal and oil. It's also very, very cheap. It's another one that, with all the infrastructure we have and the actual cost of accessing and harnessing and transporting it, it works out very cheap as well. It's relatively economical. And we also have very large amounts of natural gas here in the United States. So we have a good deal of this resource as well. But burning natural gas, again, creates greenhouse gases, not as much as coal and oil, not as much air pollution, but there is still some there. And it's difficult to store. Being a gas, it takes up much more space to store compared to the solids and liquids like coal and oil. And then a lot of the ways that we're reaching all of our natural gas reserves are hydraulic fracturing. And hydraulic fracturing contains lots and lots of materials and chemicals that can be harmful to the environment. And as those things get pumped down into wells, it can have negative effects if they're not properly disposed of and taken care of. The final non-renewable energy comes from nuclear power. And this is considered non-renewable because there's only so much of these elements on the Earth. Uranium is the most common one. There's also a little bit of plutonium that's used, but there's only so much of these resources. There's only so many of these materials out there. We can't go and put together atoms and make more uranium. So it's considered non-renewable. What occurs is you have a neutron that can be propelled and it goes and hits the nucleus of a uranium atom. That breaks the nucleus apart. Those nuclei are very loosely held together, they're very unstable, and that neutron pops it into two. As it splits, that releases a bunch of heat and a bunch of energy. It also can start a chain reaction where when that first atom breaks apart, that nucleus splits, it sends out more neutrons that are being kicked out of the two smaller nuclei. And those neutrons go on to hit other nuclei that then split and give off much more heat. And that's the big difference between a nuclear power plant and a nuclear bomb is that in a nuclear power plant, they contain and slow down the number of these other atoms that get split apart in that chain reaction. The bombs, nuclear bombs, are those uncontrolled chain reactions where just everything goes off at once. But in nuclear power, those atoms, as they break down, release heat. That heat's used just like burning other fossil fuels. It creates steam that turns a turbine and turns a generator to create electricity. Nuclear power is responsible for about 20% of our electricity. And overall in the world is about 10% of the world's electricity use. And at our current use, we have enough uranium and plutonium to last about 100 more years. Some interesting facts: when the atom is split, it's called nuclear fission. And this is how we generate electricity. It's what we're able to do in our nuclear power plants. We know that the opposite can occur where two atoms and nuclei are smashed together and they join. This would also release a bunch of energy, and it's called nuclear fusion, when two atoms fuse together, as opposed to when fission, when they fissure apart or a split. Fusion means join, fission means split. Fusion is what's occurring in our sun. The sun has such massive amounts of heat and pressure that it's able to smash together atoms to create energy. And that energy leaving the sun from fusion is what we see as light. It does not create any air pollution. Uranium's relatively cheap to produce, to actually create the uranium itself. The cost to build a nuclear power plant is much, 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 much higher compared to other places. And it's a very, very compact, very high density fuel, lots and lots of energy for the same amount. But on the downside, it creates nuclear waste, and that nuclear waste has to be stored somewhere. And of course, nobody wants nuclear waste in their own backyard. We always want it to go somewhere away from ourselves. So the question comes, where do we put it? And if those nuclear power plants do have accidents, they can have varying degrees of outcomes that can go from relatively mild effects, like in 3 Mile Island, to much, much larger effects like Chernobyl and some of the effects that they're monitoring still from the Fukushima disaster. So those can create lots of nuclear waste if a nuclear core has a meltdown or things like that. It can be very, 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 very bad. But they're very rare.